In this last video of factoring review, we're going to talk about a technique that's called factoring by grouping. And the idea behind factoring by grouping is actually something that I mentioned in our first video on factoring when we were talking about the greatest common factor, which is that the greatest common factor is not just a single term, but rather a binomial, for example, a polynomial with more than one term in it. So here's the idea. Say that you have something like this. 3x squared times x minus 2 plus 2 times x minus 2. Okay? So the idea is to notice that if you look at both of these pieces, x minus 2 is a factor these two pieces have in common. Okay, so just like in our greatest common factor video when we said, all of the factors of this polynomial are divisible by 2, so we can factor the 2 out, in exactly the same way, in this case, we can factor out the x minus 2. And so what we end up with is thinking about kind of these two terms that I have in red here. What would you multiply x minus 2 by to get 3x squared times x minus 2? That's 3x squared. And what would you multiply x minus 2 by to get 2 times x minus 2? That's plus 2. So one really common question that comes up here is, well, but there were 2 copies of x minus 2, so kind of caution. We'll call this a caution box, and I'll try to stick to making those orange. This is a very common kind of misconception here. And there's lots of ways to come at this, kind of thinking about why this is a misconception. There's lots of things you could say. One of them is coming at it from the degree angle, right? If you look at the original polynomial, the first piece, if you multiply that out, that would have had an x cubed in it. It would have been 3x cubed. Here, if you multiply that out, it's just x's and constants. So this started as a degree 3 polynomial. Whereas if you multiply this out, and I'll let you guys think about this on your own, if you multiply that out, you have 2 copies of a degree 1 factor. So just this piece here is a degree 2 piece. And then you're multiplying it by another degree 2 piece, which is degree 4 altogether. So the degrees don't line up. Another piece is that the distributive property requires us to multiply everything all the way through. So we would have to multiply the x minus 2 squared by 3x squared and also by 2. But if you look at the original polynomial, 3x squared is not multiplied by x minus 2 squared. It's only got the 1x minus 2. So you can dismantle kind of this misconception using the degree argument, using the distributive property argument. But either way you slice it, it's important to understand that the 2 pieces share only that one factor of x minus 2. Okay, so now let's look at a few examples where things are a little bit less pre-packaged. So for our first example, we will look at x cubed plus 4x squared minus 7x minus 28. So the idea behind the technique of factoring by grouping is precisely kind of what it sounds like. Rather than factoring the whole polynomial in one go, we break it up into groups. And when you say break up into groups, it really can be as however you want. So if you have a 4-term polynomial, the groups could be the first 2 terms and the last 2 terms. It could be the first term and the other 3 terms. There's lots of ways that you can group things. But for our purposes, and you'll hear me refer to this as the 2 and 2 grouping, we're going to put the first 2 terms together and then the last two terms together. So I refer to this as the 2 and 2 grouping. That's not an official title. It's just something I like to say. And it's the grouping that we use almost exclusively. It's certainly the only grouping we use in this class. Okay, so check it out. If I'm looking at this first group, what do I see? Well, I see x cubed and 4x squared. Haha, they both have an x squared in them. So I'm going to factor that x squared out. So x squared times what makes x cubed? That's x. X squared times what makes plus 4x squared? That's plus 4. So the first group factored into x squared times x plus 4. Now for the second group. So you might remember this from our last lesson, the lesson on factoring quadratics. We talked about how no matter what else might be true, positive and negative 1 are always greatest common factors. Which means that no matter what else you may be doing, you can always factor out positive 1, which doesn't do anything, and negative 1, which we're going to use here because of the signs. Now, in addition to the negative, and I'll say a couple of more words about it in a few seconds, we see 7x and we see 28. Both of those are divisible by 7. So what we're actually going to do here is we're going to factor out negative 7. Sort of a rule of thumb that I recommend here, although I'm not a big fan of rules of thumb, is watch for the sign between the two groups. If the sign between the two groups is a minus, the way that it is here, so in this I'm referring to this sign right here. If the sign between the two groups is a minus, whatever else we're going to be factoring out, we're going to be factoring the negative out with it. So that's a pretty good way to remember that, oh, that middle sign between the two groups is negative. I'm going to factor the negative out. So now check it out. We're asking, what would I multiply by negative 7 to get negative 7x? That's x. And what would I multiply by negative 7 to get negative 28? That's plus 4. Now, if I had slightly fancier software, I would maybe do like a sparkle here or some kind of other celebratory moment. Instead, I'll just put kind of a purple star, smiley face, star. This is the look of a successful grouping. So both of the groups that we started out with have turned out to be something times x plus 4. The fact that x plus 4 has shown up in both of the groups is a sign that grouping is a technique that works here. Now, I'm going to do exactly the same thing here that I did in my sort of idea introductory example. I'm going to pull the x plus 4 out, which leaves me with x squared from the first group minus 7. Now, x squared minus 7, you could try to factor that further if you wanted. It doesn't factor, so we'll leave it there, but I will do an example towards the end of this lesson where we can actually go one step beyond this. Okay, let's do a couple more examples. So for our next example, we will do 2x cubed minus 10x squared plus 3x minus 15. So again, we're going to factor this by grouping, and again, we're going to use our go-to, the 2 and 2 grouping. So for the first group, 2x cubed minus 10x squared, notice we can pull out 2x, which leaves us with, 2x squared, which leaves us with 2x minus, which leaves us with x minus 5. Sorry, I got a bit tongue-tied there. And then for the second group, notice the sign between the two groups is a plus. So I'm not going to be worrying about factoring out a negative here. I'm just factoring out the 3 because both 3x and negative 15 are divisible by 3. Okay, so we have that. And I'm not going to do the whole goofy star, smiley face, star thing, but it's there. This is the look of a successful grouping because both groups ended up being something times x minus 5. So I have x minus 5 times 2x squared plus 3, right? So again, in this case, you could try to factor 2x squared plus 3 down further, and again, it would not pan out. Okay, I want to do another example. I think I want to do 2 more, actually. So for this example, I want to try 2x cubed plus 3x squared minus 8x minus 12. Okay, so same thing. We're going to use our 2 and 2 grouping. And again, notice this time the sign between the two groups is a minus, so we're going to keep that in mind. So the first group, the coefficients don't have any factors in common, but the x's, we can pull out x squared. So we're left with x squared times 2x plus 3. Now here, we have minus 8x minus 12. And the 8 and the 12 are both divisible by 4. So we're going to factor out negative 4. So what that leaves us with is negative 4 times positive 2x would give us negative 2x. And negative 4 times positive 3 would give us negative 12. So again, ding, 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 successful grouping. This is fantastic. So at this point, we see that both of the groups have a 2x plus 3 in them. So we can factor it out. And we're left with 2x plus 3 times x squared minus 4. Now, as it turns out, and I wanted to make sure to do one example like this, x squared minus 4 is what's called a difference of two squares. I'm not going to make a huge emphasis on this because as much as I'd love for you all to know what differences of two squares are, there are ways to work around knowing about them. And for now, I'm okay if you just have sort of a vague recollection, like a bell rings off somewhere in the distance. Differences of two squares are going to come up from time to time, and it's handy to know how to factor them. You could do it by trial and error, so you could say this is a degree 2 polynomial, and so on and so forth. Maybe you remember the formula, maybe you could even construct the formula on your own. I'm not going to worry about any of that too much. What I'm just going to tell you is always do that once over. When you factored one way, look it over and see if you can factor further. So x squared minus 4 being a difference of two squares factors down into x plus 2 times x minus 2. Okay, so not always are you going to be able to keep going after you've done the factoring by grouping, but when it's possible, go ahead and do it. So I want to do one last example with you all. And the example that I would like to do with you is the following. I'd like to look at 15x cubed minus 21x squared plus 5x minus 7. Okay, so this is again a factoring by grouping problem. And you'll notice that in all of these problems, I've tailor-picked examples where factoring by grouping actually works. I'm not going to spend a lot of time talking about or showing you examples where grouping doesn't work, but I hope that you've kind of picked up from my goofy star, smiley face, star, and the notion of a successful grouping, that grouping, like any other technique, is not going to be appropriate in all cases. However, it's a useful technique, and when it works, it's really handy. Okay, so off we go. So here are our two groups. Notice that the sign between them is a plus. So we know that we're not going to be factoring a negative out in the second step. For the first group here, what do we have? We have 15x cubed minus 21x squared. So 15 and 21 both go into 3. And then both of the variables have at least an x squared in them. So for the first group, I can factor out 3x squared, which leaves us with 5x minus 7. Now we come to the second group, right? And we're not factoring out a negative, but we look at 5x minus 7, and we're not immediately seeing like a super exciting GCF. And so this is where we remind ourselves, aha, yes, no matter what, everything always has a greatest common factor, even if it's just 1. So in situations where you're looking at it and you're like, I don't see anything they have in common, never forget that 1 is always there for you. So the second group, we're just going to leave it as is and factor out the 1. And there's the look of that successful grouping. I've got 2 groups where both of the groups have a factor of 5x minus 7. So we can pull it out, and we're left with 3x squared plus 1. Now you could try, and I encourage you to. Anytime I say you can try, I'm not like egging you on or taunting you. I'm encouraging you to play and poke and see what you can find. You could try to factor 3x squared plus 1 using exactly the techniques that we used in the previous lesson. So some of you might be thinking, well, how are you supposed to do that? What would the x term be? That's a great question. Think about that. What would the x term be if you don't see the x term? What's the coefficient on that? But anyway, even if you were to poke around with this on your own time, what you would see is that in fact, there is no way to factor 3x squared plus 1 any further. So this is our little review lesson on factoring by grouping. You'll notice factoring by grouping is very handy and will come up in your first and second homework assignments. For now, this concludes our review of the factoring processes.